So I'm going to work out problem number 42, and it's a bit of a lengthy problem. I'm going to explain it step by step. If I were you, I would pause at any moment and see if you can work it from that point on. If you get stuck, you can go back and continue watching the video. But I think it's a good exercise for you to try to stretch your mind a little bit. So for problem number 42, we're going to need to use the identity for the tangent of the sum of angles. And it's going to be a variation of it. In other words, we're going to rewrite it so that we'll solve for the numerator of that fraction. We'll solve for tangent alpha plus tangent alpha plus tangent beta. So if we solve for that numerator, we get another identity, and that's the identity that we're going to use. Okay, so don't use the one that's presented in the book. Just do a version of it. So for problem number 42, basically, what we're trying to prove is that the tangent of x minus y and tangent of y minus z and tangent of z minus x, it's equal to the product of all of those tangents. Okay, that's what we're trying to show. So let's just work on the left side. And the way we're going to do that is we're going to use the identity that we just showed. And for alpha, I'm going to use x minus y. That's my alpha. And for beta, I'm going to use y minus z. So remember that identity that I just recorded. And let's go ahead and rework this. Just the first two, the tangent of x minus y plus the tangent of y minus z. We're just going to focus on those two guys first. So using that new identity that we came up with, we're going to add alpha and beta together. In this case, it's going to be x minus y plus y minus z times 1 minus the tangent of x minus y times the tangent of y minus z. And then we'll go ahead and add on that tangent of z minus x. We'll deal with him later. Okay. So you'll notice that by combining those two together, we get rid of the y variable. The y's simplify out, and we end up with the tangent of x minus z multiplied by all that other stuff. Now I'm going to take that tangent x minus z, and I'm going to distribute it across the parentheses. So I'm going to distribute it to the 1 and to that other expression. So when I do that distributing, I'm going to end up with, and this is going to be quite lengthy, but I'm going to end up with the tangent of x minus z. That's what I get when I multiply that to 1, minus, and then I'm going to get the tangent of x minus z times the tangent of x minus y times the tangent of y minus z, and then I have that other straggler that I'm going to deal with later, the tangent of z minus x plus the tangent of z minus x. Remember that tangent is an odd function. In other words, the tangent of the opposite is equal to the opposite of tangent. Do you remember that? So the tangent of z minus x, that last term that I'm looking at, is equal to the opposite of the tangent of x minus z. I'm taking the opposite of my domain and the opposite of my function. Those guys are equivalent. And the reason I'm going to do that is because now that first term and the last term, they now cancel with each other. So you had to remember that those two functions are odd. It's an odd function, so you can rewrite tangent using that one identity. And now what I'm left with is the opposite of negative tangent x minus z, x minus y, tangent x minus y, tangent y minus z. We're almost there, guys. I need to get rid of that negative out front. And remember, what we're trying to show is that the tangent, we're not trying to show the tangent of x minus z, we're trying to show the tangent of z minus x. So I'm going to use that identity, the fact that the tangent is an odd function. I'm going to use that identity again. So I'm going to keep those two guys, the tangent of x minus y and the tangent of y minus z. I'm keeping those, but I want to get rid of that first guy, and I'm going to use that identity, and the opposite of the tangent of x minus z, that's equivalent to the tangent of z minus x. And then we just keep the other factors. And there's your proof.